morning, everybody. It's my pleasure to be here and share some of our findings on this pilot study on microplastics, where we are addressing one of the major sources, which are the landfills. So let me see if I can change my pointer. Good. So we are all familiar with the floating islands of plastic in the ocean. It's like the most evident and alarming example of plastic in the world now. It's been reported in the news, in documentaries, in the scientific literature, and we know like we are producing all that plastic from terrestrial sources and fishing activities. And we know like all the effects that fish can eat them or they get trapped in those nets. So as Dr. Coffin was showing also, there is this non-profit organization, the Ocean Cleanup, which deploy these giant nets to capture that plastic, and they say they recycle it and they make sunglasses. We can get those recycled sunglasses for about $200, but we know the problem is more complex than that, as the plastic breaks down into microplastic with the absorption of solar radiation. So this is a sample of actual microplastics in the environment. If we look at the scale, this is 500 microns, which is 0.5 millimeters, and most of the plastics are way smaller than that. So in fact, there is a recent paper that shows that if we take boiling water into one of the regular coffee plastic cups that we get in Starbucks, after 20 minutes, we get billions of nanoparticles in there. So I don't think we can capture those these particles of these sizes with those giant nets in the ocean. And also the reality is like not all plastics can be recycled. So if we look at the USA facts, we see like only about 10% of the plastic can be recycled, and then 80% just go to the landfill. So the next question would be, does the life of a plastic end in the landfill? And the answer for that is no, because we know like in this environment, plastic also breaks into microplastics, and then with rainfall, they come out of the landfill into the leach. So if we look at here in the US, before 1991, landfills were not regulated, and the leach was able to escape directly to the soils and groundwater. But then after 1991, there was this regulation that all new landfills have to be bottom line with and collect that leach and send it to wastewater treatment plants. So our job was take samples of the leach before getting into the city sewer, take also samples of the city sewer, and then the outputs of the treatment plant. So we found that we found plastics everywhere, of course. So but 10% of the plastic into the city sewer were potentially coming from the landfill, the landfill leach. And then we found, as in other research has been shown, that wastewater treatment plants do not actually degrade the plastic. So everything that comes in comes out, most of them to the biosolids. So 99% of the microplastics accumulate there, and 1% it's released directly to the rivers in the effluent. So either way, microplastics can escape from old landfills directly to the soils, or they can go this way around and again be applied to crops and reach the soil and groundwaters. We also found in our samples that 30% of the microplastics in the city sewage was fibers potentially coming from clothes and our washing machines. So there is this paper that shows that every time we put out 6 kilograms of clothes in every wash, we are creating hundreds of thousands of microplastics. So Dr. Coffin was also talking about this, that there is an opportunity for startups to design filters to avoid that these fibers get into the city sewage. But so is it the solution for the problem? So as he was also mentioning, if the fibers that they capture have to be sent to the landfill. So again, it goes back to the landfill, to the same cycle, that the same system that I was showing before. And also in California, as he was showing, there are some regulations. So people are already encouraged to use these filters, but if people is not obligated or encouraged, like very few can actually invest in something like this. So now there is this other system. There is a whole industry of private pre-treatment plants. So there is new regulations also to the food companies and pharmaceuticals and also landfills that they cannot release the wastewater directly to the city sewers, but it has to go through a pre-treatment process. So we also had access to this kind of system, and we sample the leachate before the pre-treatment plant and after to see what are the effects of this treatment plant. We found in this case, so in the leachate we found 1,300 microplastics in 50 mils, which is about 100 parts per billion. This plot is showing the size distribution of those 1,300 particles. So we see that the smaller that we go, the more particles that we find. Now, after the pre-treatment process, we see also kind of the same trend as in the municipals wastewater treatment plant. So 1% of the plastic goes to the effluent and 99% accumulates in the biosolids. So, but we found when we plotted the size distributions, we found that the distribution was skewed towards the left. So that means a smaller particles. So this size came in and then they came out like smaller than that. So, but the treatment actually doesn't degrade the plastic, but just making it smaller and smaller. So in the biosolids, we found 4,300 particles in less than 2 grams, which give us 1,800 parts per billion. Now, we can think of a solution to filter the microplastics here before they get into the tankers. But again, if there is no regulations and the landfills are not obligated to that, like they are not going to invest on a solution like that. So we can create a filter as in the same case as similar to the washing machines, but we need also the regulations that make them do it and apply it, and also have a plan of what to do with those microplastics that we capture there. If we just simply send it back to the landfill, like by circulating them forever. So, but in the meantime, we already know 99% of the plastic goes to the biosolids. So what can we do with that? I think as a scientist, we can spend time studying the transport of microplastics into the soil, which is a very complex problem if we consider all the variables that are in that environment. So there is air and water boundaries, surface charge. There are minerals, chemical reactions going on, and microbes. So from my background, so I know that it's already a well-developed reactive transport theory for porous media, but it doesn't apply to microplastics. As we know, they come mostly in the forms of fibers and fragments. So the same drag forces do not apply in this case. So basically, they do not behave as a soluble substance that travels in the porous medium. So we need a lot of experiments and math to make accurate models to estimate the effect of the plastic that are already in the soil and groundwaters. So just to wrap up, a brief summary. So we learned that landfills receive the vast majority of plastic waste, which most of the plastic cannot be recycled, excuse me. So even if we replace all the plastic that we use today, there is millions of tons of plastic already stored in the landfills that are coming out in the form of microplastics. So they come back into the environment via the leach in concentrations of parts per billion, as we found in our results. We found that traditional wastewater treatment processes do not degrade microplastics, but they can be found again in the biosolids and the effluent. 99% accumulate in the biosolids which are land applied. And in the meanwhile, new regulations apply. We can do some improvements to transport models in porous media to help estimate the spread of microplastics in soil and groundwaters. So thank you for your attention. I can take any questions now.
Thank you, Andres. We do have a question.
Yes, so we had an attendee who was curious if you could speak to unlined landfills. In many towns, waste dumps and Superfund sites, there is no liner beneath the landfill. Do we know anything about leaching directly into groundwater from unlined landfills, especially a concern as sea levels rise and come into contact with unlined landfill materials?
Correct. Yeah, so that's what I was trying to explain here. So before the regulations to landfills, they were unlined and the leachate was able to infiltrate directly to the soil. So yeah, there is many landfills like that. And as I was saying, even if we replace all the plastic that we use now, there is already tons of plastic stored in landfills that can get out of there through the leaching. So that's why one of my conclusions is just we need to improve on our understanding of how they are transported in the soil to actually estimate how fast they move or how far they can go if they get into the groundwaters.
Sarah, do we have time for one more?
Yep, we do. Okay. We have a couple minutes still.
An attendee was curious about microbial or chemical degradation or continued transport in shallow and deep aquifers.
Mm-hmm. Yeah. So let me go back here. Yeah. So as I was saying, like, I know it's a very complex problem that has to be tackled from different background and expertise. So right now here at the Illinois Sustainable Technology Center, so we have chemists, we have geobiochemists, we have engineers that we are all working on understanding and the transfer of microplastics into the soil. So we have to start little by little. The first step is like the physics of how water can transport that, and then start adding like or making more realistic by adding the, as I mentioned here, the surface charge, the mineral reaction, microbes, etc. So it's a whole problem that will take some time to come up with an accurate model